right, so an auto insurance company insures drivers of all ages. An actuary compiled the following statistics on the company's insured drivers. So, age of driver 16 to 20, probability of accident given that they're in this category is 0.06. So, the probability that they have an accident given that they're in that category is equal to 0.06. And the probability or I guess the portion of the company's insured drivers that are 16 to 20, right, is equal to 0.08. So D1 will just be the first category that they gave us, right? So probability of the accident given D2. So the second category, 21 to 30, is equal to 0.03, having an accident given there in that category. And the portion of people that are in that category is 0.15. Okay. Now, over here, probability that they have an accident given they're in the third category is equal to 0.02. And the probability, I guess the portion of people that are in that category, the third category, is 0.49. And then lastly, we have the probability accident given, they're in the fourth category, is equal to 0.04. And the portion of people that are 66 to 99 is 0.28. All right. So they tell us a randomly selected driver that the company insures has an accident. Okay. Calculate the probability that the driver was age 16 to 20. So they want the probability that they were in the first category given that they had an accident, right? So that's what they're looking for. So let's go ahead and apply the definition of conditional probability. This is the probability D1 intersection A over the probability of A. And now you'll see why I drew this. Notice that all of these add up to 1 and they are completely mutually exclusive, right? They're separated. So you can see that A is accident, so it takes a chunk of all of these drivers, right? They had an accident. So you can actually rewrite this. So let me scoot down a little bit. You can rewrite this here. So first, I'm going to move this around here. So this is the probability of A intersection D1. And for the probability of A, you can rewrite this as the probability of A intersection D1 plus the probability A intersection D2 plus the probability A intersection D3 plus the probability A intersection D4, right? Because A is all of this, right? So A intersection D1 is going to be this green part, right? A intersection D2 is going to be this red part here. Let's get cyan. A intersection D3 will be this blue part. And A intersection D4 would be this purple part, right? So, as you can see, let me get that black. The probability of A is also the probability of each intersections added together, right? So, now we're going to use the definition of conditional probability again to say that this is equal to the probability of A given D1 times the probability of D1, because that's the same thing as the probability of A intersection D1, over, so this will be the probability of A given D1, probability of D1, plus probability of A given D2, probability of D2, plus probability of A given D3, probability of D3. Let me scoot this a little bit. And then plus, finally, probability of A given D4. Oh man, I still gotta scoot it a little bit more. Okay. Times the probability of D4. Right? So this is actually Bayes' theorem, right? the probability of D1 given A is equal to the probability of A given D1 times the probability of D1 plus over all of these guys. So this is actually Bayes' theorem, but I thought it would be a good idea to illustrate how Bayes' theorem is constructed, right? Using some intuition. All right, well now, this just becomes, you plug in some numbers. So this is equal to, so probability of A given D1 is 0.06 times probability of D1 is 0.08 over, so this is the same thing, 0.06 times 0.08 plus probability of A given D2 is 0.03, 0.03 times probability of D2 is 0.15 plus the probability of A given D3 is 0.02 times 0.02, and then probability of D3 is 0.49 plus, and then lastly, probability of A given D4 is 0.04 times probability of D4 is 0.28, and then this is equal to 0.1584. So the probability that the driver was aged 16 to 20, given that he had an accident, right? Given that he had an accident, is about 16%.